Imagine yourself standing in the heart of a raging ocean, where towering walls of water, as high as 10-story buildings, crash down, threatening to crush everything in their path. In the swirling mist of spray and the terrifying roar of the storm, even the multi-billion-dollar supercarriers of the U.S. Navy seem insignificant in the face of nature's fury. Could these colossal steel fortresses be swallowed by monstrous waves in an instant? Or is there a hidden power that allows them to stand firm on the brink of life and death? Today, we will unravel previously undisclosed secrets. From breathtaking confrontations between humanity and the sea, to technological breakthroughs that have transformed aircraft carriers into invincible entities against any fierce storm. Let's begin our journey exploring the relentless battle between human ingenuity and the destructive power of the blue ocean. The ocean is not just a dazzling spectacle of shimmering beauty or gentle waves lapping the shore. Deep within lies a deadly, perilous black hole. For naval soldiers, each voyage is a life or death confrontation with unpredictable forces of nature. The most terrifying of these is the monster wave, a devastating entity whose terrifying existence is acknowledged by modern science. These are not products of science fiction, but towering walls of water, sometimes 30 to 90 meters high, appearing suddenly like a ghost in the open sea. They form when extremely powerful ocean currents collide head-on, propelled by raging storms. Imagine a colossal mass of water weighing millions of tons, moving at lightning speed, and ready to crash down on anything in its path. The power of rogue waves can shatter even the most robust steel structures, turning massive transport ships into rubble in seconds. Even for supercarriers, considered impregnable fortresses on the sea, this type of wave remains a real nightmare. A direct collision can cause the entire hull to shake violently, paralyzing the electronic systems and completely damaging dozens of modern fighter jets on board. Besides rogue waves, Category 5 superstorms with wind speeds exceeding 110 kilometers per hour are also a formidable enemy. These storms not only generate massive waves, but also alter atmospheric pressure, causing severe instability to the steering system. Maritime history has recorded painful lessons like the tragedy of the El Faro, a stark reminder that the sea never shows mercy. When a ship enters the eye of a hurricane, all traditional experience and techniques become meaningless without thorough preparation. For the U.S. Navy, protecting assets worth tens of billions of dollars and the lives of thousands of crew members is a critical mission. A small misjudgment in assessing the storm's strength can lead to a strategic disaster, weakening the deterrent power of an entire fleet on the world military map. The sea is an arena of resilience, where only the perfect combination of cutting-edge technology and human fortitude can help us stand firm against the brutality of nature. For a floating city weighing hundreds of thousands of tons to withstand the immense force of the ocean, the answer lies not only in engine power, but also in the most fundamental laws of physics. Let's explore the art of hull construction, where natural laws are utilized to transform a colossal block of steel into a flexible entity on the water's surface. First, we must mention Archimedes' principle of buoyancy, the universal key that allows super-heavy objects to float. By designing an extremely large displacement volume, the aircraft carrier generates a powerful upward lift, counteracting the tremendous weight of dozens of layers of steel and equipment. However, buoyancy is only the beginning. The most difficult problem is how to prevent the ship from capsizing when monstrous waves constantly attack from all sides. The key to this stability is the principle of a low center of gravity. Imagine the aircraft carrier as a giant tumble doll. Military engineers cleverly position all the heaviest components, from the nuclear propulsion system and fuel tanks to heavy machinery, down to the bottom of the ship. This arrangement creates an invisible gravity anchor, allowing the ship to maintain its upright balance even when tilted at a significant angle. It is this intelligent weight distribution that allows the aircraft carrier to withstand strong oscillations without losing its core stability. Delving deeper into the external structure, we see the marvel of the V-shaped hull design. Unlike civilian ships with flat bottoms or U-shaped hulls, which are primarily focused on cargo capacity, the V-shaped hull of the aircraft carrier is likened to a sharp blade forged to pierce through the water. When faced with walls of water tens of meters high, instead of being pushed back and tossed around like a dry leaf, the V-shaped design allows the ship to cut through the waves, smoothly, parting the water to the sides. This not only minimizes the impact force on the ship's structure, but also maintains stable speed and direction in rough seas. In addition, this design optimizes the flow around the hull, minimizing water resistance, allowing the super aircraft carrier to move at incredible speeds for timely combat deployment. The combination of hydrostatic propulsion, a solid steel center of gravity, and a sharp wave-cutting structure are the three solid pillars that form the foundation for the survivability of American aircraft carriers in the turbulent ocean. It is a symphony between human ingenuity and the immutable laws of the universe, ensuring these fortresses never succumb to the fury of the blue sea. If the hull design is the sturdy framework, then modern balancing systems are the sensitive nervous system, allowing American aircraft carriers to maintain an extraordinary calm even in the midst of a storm. Imagine steering a giant steel city and the ocean trying to capsize it. To counteract this force, the U.S. Navy employs a trio of cutting-edge technologies, working seamlessly as a unified machine. First is the intelligent ballast system. These aren't just ordinary water tanks, but a network of compartments arranged along both sides of the ship. When a large wave hits the port side, causing the ship to tilt to the right, a system of extremely powerful pumps immediately transfers thousands of tons of water to the opposite side. This active weight shift creates an instantaneous counterweight, pulling the ship back to a balanced position. Much like a tightrope walker uses a long pole to maintain balance against strong crosswinds. Next, we must mention fin stabilizers, also known as technological fins, beneath the sea surface. Hidden deep beneath the ship's hull are giant propellers capable of flexible movement. They operate on a principle similar to aircraft wings, but instead of creating lift in the air, they generate lift in the seawater. When sensors detect the ship beginning to roll sideways, these fins automatically change their angle of inclination in an instant. The hydrodynamic lift generated by the water movement pushes the sinking hull upwards, and vice versa. This continuous adjustment helps to counteract small but intense oscillations, ensuring the deck remains stable enough for fighter jets to take off and land safely even in rough seas. Finally, and perhaps the most sophisticated technology, is the gyro stabilizer system, or giant gyroscopes. Remember the image of a toy spinning top. No matter what impact it faces, it always remains stable as long as it continues to spin. Applying this principle, engineers installed heavy metal blocks weighing tens of tons inside the aircraft carrier's enclosed compartments, rotating them at a maximum speed of over 10,000 revolutions per minute. The moment of inertia generated by these gyroscopes creates a powerful resistance against any attempts by ocean waves to tilt the ship. Remarkably, this entire process is coordinated by artificial intelligence, allowing the system to analyze and react even before humans notice any changes in the water surface. The combination of the weight of the water current, the flexibility of the fins, and the physical power of the gyroscopes transforms the aircraft carrier into an immovable fortress against any storm, affirming the dominance of modern military technology over the oceans. No matter how modern and sophisticated a machine is, it becomes useless without meticulous steel maintenance and an extremely sensitive long-range warning system. For the U.S. supercarriers, safety in the vast ocean stems not only from their steel hulls, but also from meticulous attention to even the smallest details. Maintenance here is elevated to a military art, divided into two distinct fronts: prevention and repair. Every day, thousands of sailors conduct rigorous inspections, from measuring the vibrations of massive nuclear engines and checking every millimeter of pressure in the hydraulic systems to cleaning and lubricating every mechanical joint on the deck. Every bolt, every weld carries the fate of an entire fleet. Even so, these steel monsters must be periodically moved into dry dock, where they are completely isolated from the water so that engineers can inspect the ship's underside, which is subjected to severe corrosion from sea salt that is invisible to the naked eye during operation. However, prevention is never enough if the ship inadvertently plunges into the fury of a Category 5 super typhoon. Therefore, weather forecasting is considered the ultimate strategic weapon, helping aircraft carriers always stay one step ahead of nature. The U.S. Navy doesn't just look at the sky with the naked eye. They possess a dense network of all-seeing eyes in orbit. Modern meteorological satellites constantly scan the oceans, recording even the slightest changes in cloud formations, sea surface temperatures, and underwater currents. This massive amount of data, combined with information from wave-measuring buoys and long-range radar, is fed into supercomputers capable of processing billions of calculations per second. Here, sophisticated algorithms will simulate the entire storm scenario for the next few days with astonishing accuracy. Instead of directly confronting monstrous waves tens of meters high, fleet commanders can rely on heat maps and wave models to map out an optimal route. They can adjust speed, change the angle of movement to glide around the edge of the storm, or choose a calmer area to take shelter in while still ensuring the combat objectives are met. This intelligent avoidance not only protects human lives and valuable equipment, but also saves millions of liters of fuel and maintains the highest state of combat readiness. The combination of the skillful hands of maintenance workers and artificial intelligence from space has created an invisible shield, ensuring that even when nature is at its most furious, American aircraft carriers will always find a safe path to continue their mission of dominating the oceans. No matter how sophisticated the mechanical systems or how intelligent the artificial intelligence algorithms, the true heart that helps an aircraft carrier overcome adversity is human resilience. In the midst of the raging ocean, where the line between life and death is as thin as a hair, it is the steely discipline of the crew that determines the fate of this steel fortress. Imagine a floating city with over 5,000 people, each a vital link in a colossal machine, from the engineers in the sweltering engine room to the dispatchers on the windy deck. Everyone must maintain absolute alertness in the face of violent sea conditions. A moment of carelessness in securing the watertight compartments or a small mistake in securing equipment can lead to irreversible chain reaction disasters. Therefore, the U.S. Navy's training process goes beyond theoretical learning. It's about honing survival instincts into unconditional reflexes. Sailors must undergo emergency drills repeated thousands of times until every maneuver becomes flawless in the dark. They learn how to control damage when a ship's compartments are flooded, how to control fires at sea, and how to coordinate seamlessly to rescue people who fall into the water in the most extreme weather conditions. These exercises are designed to push human endurance to the limit, forcing them to remain calm amidst the blaring sirens and the suffocating pressure of monstrous waves. Entering the digital age, training has been elevated to a new level with the support of virtual reality technology. Instead of waiting for real storms to gain experience, sailors can now enter hyper-realistic simulated environments. In the virtual space, they will face Category 5 super typhoons, walls of water tens of meters high, and the most severe system failures. This technology allows them to experience extreme terror and psychological pressure while ensuring absolute physical safety. Artificial intelligence will monitor every heartbeat and every decision of the sailors in the VR environment to provide in-depth analysis of each individual's strengths and weaknesses. The combination of rigorous traditional training methods and cutting-edge simulation technology has created fearless crews. They operate the ship not only with skill, but also with a spirit of solidarity and unwavering faith in their teammates. When monstrous waves crash, machinery may shake, steel may twist, but the will of the people on board remains as firm as a rock. That is the final and most important secret, transforming American aircraft carriers into enduring symbols of strength and resilience against the fury of the blue ocean. We stand on the threshold of a new era, where the steel fortresses of the ocean are no longer static blocks of metal, but are gradually transforming into powerful, intelligent entities. The future of aircraft carriers lies not only in their enormous size, but in the convergence of revolutionary materials, technologies, and cutting-edge artificial intelligence. One of the most groundbreaking advancements is a fundamental change in the ship's structure. Instead of relying entirely on traditional, heavy steel plates susceptible to corrosion from seawater, military engineers are moving towards the use of next-generation composite materials. These ultra-durable, ultra-lightweight materials not only reduce thousands of tons of excess weight, but also provide exceptional resistance to impact and pressure from monstrous waves. As the hull becomes lighter and more resilient, the maneuverability of the super aircraft carrier will be pushed to unprecedented heights, allowing it to glide across the turbulent sea with astonishing grace. But the marvels don't stop there. Imagine transforming hulls, a concept seemingly only found in science fiction films, in the not-too-distant future. The exterior of an aircraft carrier could physically change shape to adapt to different sea conditions when speeding through waves is needed. The hull would shrink like a sharp blade to cut through the water's surface when facing fierce storms requiring absolute stability. Parts of the hull could expand to increase the contact area, creating a solid support like a fixed island in the middle of a raging ocean. This is a revolution in design, transforming the ship into a living organism capable of self-adjustment to survive any challenge of nature. The soul controlling all these complex systems is artificial intelligence and a dense network of sensors. AI will not only play a supporting role, but will become a central nervous system processing data at the speed of light. Millions of sensors embedded deep within each layer of material will continuously measure water pressure, wind speed, and the ship's tilt in real time. Even before a giant wave hits the side of the ship, the artificial intelligence will have already analyzed its trajectory and command the automatic balancing system to make thousands of microscopic adjustments. From regulating the ballast tanks to changing the tilt angle of the stabilizing fins, everything happens completely automatically and with millimeter precision. More profoundly, AI also has the ability to learn from past voyages. Each storm it has faced will become a valuable lesson, helping the algorithm to become increasingly refined to better predict and react to unexpected situations. The combination of smart materials, transformative structures, and artificial intelligence will turn aircraft carriers into entities virtually immune to the ravages of the ocean. This is the key factor enabling the U.S. Navy to maintain absolute control over all seas, regardless of how harsh the weather conditions. These floating fortresses of the future will no longer flee from hurricanes. Instead, they will boldly navigate through the eye of the storm, affirming the boundless power of human intellect and the desire for conquest. The journey to uncover the mysteries behind the power of the U.S. super aircraft carriers has come to an end, but the echoes of the battle between humanity and the ocean remain. Together, we've journeyed from the nightmares of monstrous waves, towering walls of water, tens of meters high, capable of crushing everything, to the heartbreaking tragedies of maritime history. The blue ocean has never been a peaceful place. It's always ready to unleash its most terrifying fury to test human resilience. Yet, the steadfast presence of these steel fortresses in the heart of the storm proves an undeniable truth. When intelligence, technology, and unwavering will combine, no natural barrier is insurmountable. This power doesn't come from a single element, but from a perfect symphony of modern science. It's the masterful application of the physical laws of propulsion and center of gravity, the sharp V-shaped hull design that cuts through the rough waves, and the sophisticated active stabilization system with gyroscopes rotating at tens of thousands of revolutions per minute. We've also seen the importance of satellite eyes and supercomputers for weather forecasting, helping the ship always maintain control of its course and stay one step ahead of nature. But above all, the soul of these colossal machines is the human element, the steely disciplined crews, who have transformed their survival instincts into professional reflexes through hyper-realistic virtual reality training, are the decisive factor in bringing the ship safely back to port after each stormy voyage. Looking to the future, with the emergence of ultra-durable composite materials, transforming hull technology, and deep learning artificial intelligence, aircraft carriers will no longer be just a means of warfare, but a symbol of humanity's aspiration to conquer the limits of its capabilities. Nature can be brutal, but it is relentless creativity and unparalleled courage that have enabled us to stand firm and venture further across the vast oceans. The story of the American aircraft carrier is not only a lesson in military technology, but also a reminder of the relationship between humanity and the ocean. We do not subdue nature through violence, but conquer it through understanding and living in harmony with the laws of the universe. If you found this information interesting and want to continue exploring the dramatic world of military affairs, don't forget to subscribe to the Military Stories channel to stay updated with the latest content. Your support is our greatest motivation to continue bringing you insightful perspectives and untold stories. Goodbye, and see you in the next videos.